Hi. For those who aren't familiar with me, it's my third time talking at the LDBC. I'm a regular guest. I try not to be, but it happened that way. And for those who remember, 2 years ago I gave a presentation which called almost the same title, which was the Uniprot Sparkle endpoint, 20 billion triples in production. We have a few more. We said we wouldn't. If you go back to that video, I said we'll never have 20 billion again. Unfortunately, we do. And that's going to grow again with another billion next month. So we always get this question like, why are you so crazy to provide a free public Sparkle endpoint for the whole world to use? Well, why are they having Sparkle? We have to deal with the fact that our data is ambiguous, especially in biology. We don't really know the truth of it all, and it's all very, very dirty. Other side, all the scientists have to ask novel questions. They have to ask new questions. They don't want to ask the question that was already asked before. So if we start optimizing too much to a certain query pattern, then in the end we aren't supporting our users because their query patterns keep on changing. Like many databases, we have the problem that we have lots of different kinds of information. Not just lots of one type of information, but lots of different types of information. That variety makes life difficult as well. And as a publicly funded institute to provide data to the public, we should actually make the data public. That is already a very high bar to reach in our community, but it is something that our funders require. And we need to deal with the fact that our community just knows more. So having just an isolated database, an isolated data warehouse is not acceptable. And we've come to realize that many of our problems that we have aren't actual technical problems. Technical solutions are easy to solve. Social problems, people don't liking each other, funding issues, those are really very tricky. But setting up a database, even a very annoying, difficult to install database, that we can all do. Making people like each other and share their data, that is very hard. Now, a public Sparkle endpoint is just really a wide form where you can type in queries. We try to make it a little bit nicer, but making links to the documentation and news and things like that. But in the end, it's a little simple site from the user perspective. Now, when we set up our system, we always set up that we started with the problem when we started was like loading the data was difficult. That is no longer the problem. 1.5 billion triples on commodity hardware per hour is really per second. Per hour. It writes per second on the slides, but it is per hour. 1.5 billion per hour. It's doable, especially if you don't have a full text index or something like that. We also make the RDF files available on the FTP. So now it's more than 400 files. We used to have 3 or 9 big files. Now we have lots and lots of small files. If you want to do some benchmarking on Uniprot yourself, check the void.rdf file and the release.meta files, which makes downloading much faster. Well, we're providing the data for outsiders. So people ask us, what about uptime? What about SLAs? How do you deal with that? Well, it's free, so don't complain if it's down, right? We make a best effort, and that works. We do that for our normal website as well. We tend to have now the same kind of bugs that taking out both data centers going down, file handles running out, memory leaks in our code are the common things. Resolution problems is like we had a problem with the Sparkle endpoint over Christmas. Well, yeah, we were away. We ended up having a similar problem on our normal website during a normal week. Downtime was 5 minutes. That just happened to be the difference. We have some real challenges as a public-facing endpoint. People ask difficult questions, have hard queries to answer in a reasonable time. At some point, these ones start to pile up because they come back and try it again if it didn't work the first time. You might have an automated script which tries to monitor some stuff as the semantic web researchers, and you run the same really annoying query again and again, and you start piling up at some point. So we try to limit that to 10 hours of execution time. But that isn't always working, and it doesn't always kill nicely, and we sometimes have issues there. When you talk about trying to answer difficult queries, and you try to do it over HTTP, you actually notice that HTTP is very, very fragile in practice. If you don't reply quick enough with the first byte, clients will drop the connection after 2 or 3 minutes. Another challenge we're dealing with is the semantic web researchers. Not the biologists. The biologists ask sane questions and read the documentation. But semantic web researchers just run the most silly queries all over it. They're really annoying and quite difficult to deal with because you just do regexes on all our data. To ask for data that you can read from the documentation is not going to be there. Just to see if the data is there. That is, quite a challenge. There are bugs in the implementation, bugs in all the implementations we've ever tested, and those are a serious problem as well. Not being quite up to date with the standard makes it very challenging. But most of those have solutions. And one of the main things to get a good uptime is basically have a share nothing architecture, have different data centers, have different nodes, have a load balancer about it, in front of it. We actually use Virtuoso. We're very happy with Virtuoso, especially for the price. Try to be good users and be supportive of them. And it's been really a pleasure to work with it. They're not very big machines, 64 CPU cores, AMD machines that we have, 1/4 terabyte of RAM for them, and 2.5 terabytes of consumer SSDs. And that works, they're very nice. We have another machine for the loading and testing, and it's been very, very smooth. We bought these machines 3 years ago, and it looks at current usage and data growth. We can keep on using these machines for another 2 years, which is very, very pleasing. So that was not an expensive setup. Or at least I didn't think it was an expensive setup. But what about the users? We have a nice Sparkle endpoint. What happens? Do people actually use it? Yes. And crazily enough, they actually write their own Sparkle queries. So it's not just tools, it's not just APIs, we actually have a lot of users. Now, the normal UniProt website in a certain month has 500,000 users. We don't get that on Sparkle endpoint. But we are trending, slowly but certainly, to 2,000 different people writing Sparkle queries. So we're basically providing a database for 2,000 software developers and business analysts in the bioinformatics world. That is not a number we expected. When we were in beta, we had about 250, almost 300. And now we have more than 1,700 people writing Sparkle queries on our endpoint. And we know these are people because we go on holiday. This is August, beach, they're gone. There goes our users. This curve of September, end of school year, kind of is what we see on our normal website as well. This is, completely coherent with the normal website statistics. These peaks are just more extreme on the normal website. Holiday weekends, same kind of difference in dips. We can really see that they behave exactly like what Google Analytics memphis on a normal website. So we know they're not bots, and that is really key. But it is a crazy amount of number on your database when you have 1,700 people writing queries on your database. That is a number that is much, much higher than we ever expected. And they don't care about the same things, they care all about different things. And you have very, very different query patterns. What we also found out is the main UniProt website is very performance focused. It has been very performance focused for a very long time. But we always looked at the data one way. And that was great. We've been doing that for 30 years. And then our funders and users said, well, could you look at the data that way? The other from up down. And then we said, well, yeah, we need to do some major rework there. We need to do it all. Lots of code differences. We had a key value store, and now we need to make very different values. And the developers were on the front end, the visualization guys were saying, well, can't we just have some JSON already? And at one point they said, okay, here's a Sparkle query. It generates JSON result set. It's almost a JSON you wanted, has some extra stuff, just ignore that. And you can start developing the software with it. You can start making the visualizations with it. And then we actually found enough that the Sparkle server was more than fast enough to drive that kind of traffic that we expect for it. With these kind of queries come back in about 100 milliseconds. They're very focused, 200 milliseconds. It's very, very rare data. But for us, it has a big advantage because we already had the Sparkle endpoint. It already was maintained. We didn't have to do any new development for making this feature available because Sparkle Endpoint took care of it. And what it is actually a graph which was seen very earlier, is a two-level interaction graph. So again, hairballs look very nice in presentations, but they're completely useless. This is a visualization which is slightly different, which is again a heat map of interactions, protein-protein interactions, which all our competitors on the biological databases side present as hairballs, spoken hub diagrams, and nobody understands them. But that's what the tooling gives. I'm going way too fast. I'm sorry. Differences from benchmarks. The query load is extremely unpredictable. You can have a guy come in who gives us extremely difficult queries and then disappears. We might have 200 million queries coming in an hour because somebody does a cross-join with another large database over the net. The very long-running queries, which pile up all our threads, and it never stops. Benchmark run ends, lasts an hour, you go home. And for us, it's really been a challenge to figure out when does it break and how can we plan around that. What kind of point do we need to put in rate limiting? Can we have any kind of automated query detection that says, well, this is going to be a hard query, we have to limit that to a certain number per IP. Compared to the queries in the benchmarks, especially the LDBC console benchmarks, our queries are much, much bigger. Those 1,700 people, they type long stuff. If you are familiar with the Oracle implementation, you have 4,000 characters, not close to enough. 32,000 characters, we have had queries which are longer than that somebody had a query which is bigger. From our users' perspective, we also see they're asking us to implement more and more custom functions, which we have completely refused to do at this point, but you do ask about that because they basically want us to also provide compute. We have the data, they don't want to take the data out, download it all, do a little bit of compute, and then forget about it. You're saying, well, the download is much, 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 much more expensive than the compute. And if you actually look at providing this kind of service on, Amazon Cloud, Google Cloud, the bandwidth is expensive. Compute is cheap. So if we can do more compute on the database side for people on cloud providers, it'd be great. So for our users, custom functions are a real use case. And I really do want to point out our queries in biology are long. They're really, really long because biology is complicated and you get really, really complicated queries. And this goes on for a bit longer. This is the end. We also have a problem. We still have a lot of string manipulation going on here. We do concat the string and then do a lot of work on it. So yeah, a custom function would really have helped it. But Spark 1.1 can do these kind of queries. Another difference from benchmarks is we have a larger data model. And what I mean is not we have more data, we have more classes. Our data, we have 170 classes. It's not an extreme amount for biological models. The semantic network benchmark, the social network benchmark, has 12 classes. We have 139 predicates. You guys have 15. That's a real difference. Another problem is our data model keeps on changing. We've been around for a long time. Our first pre-beta was about 80 million triples. That was in 2005. The Oracle guys might remember that. He did an early VLDB paper with that around that time to show that he could actually do what later become Sparkle-like queries. And now we're in 22 billion. We had 20 billion in between, then we went down to 16 billion, now we're back to 22 billion. And it keeps on changing. We also have people doing reasoning kind of benchmarks, and they say, look, we can do it. And well, 2 months before we had 1 billion more IL same as statements that we then just removed and replaced with SCOS exact match. And then you say, look, we're so much faster than the competitor. No, the data is completely unrelatedly different. The next thing is, that if you don't have good data, people don't come and query it. You can have horrible, horrible data formats, horrible, horrible database APIs, if the content is good. But people do like it when the nice APIs are available. And for us, we have a very, very large team, especially on the content side and on the development side, which makes Uniprot possible. I'm just the guy who does the Sparkle and front-end coding. And at this point, I would already like to say, give me questions. And I'm sorry for being much faster than my time slot allowed.
It's great to know that the customers like these or execute these Sparkle queries. Are they people building them on their own, or are they mainly just reusing the things that?
No, they're completely their own queries. They're not us saying these are the 12 example queries, these are the visualization queries. No, they're completely novel queries that aren't at any way derived or even similar to many of the other 1,000 users. So there's some API usage. Some people have built APIs against our endpoint. You can see that. But there's also a very large content or group of users which actually write their own Sparkle queries. And that is a really high number. And I'm still very surprised about that. But there's very little overlap between those users in the area of interest and the approach that they take to writing the queries.
And I'm curious, could you, everything you have here in RDF, would you also be able to do it with a property graph data model?
Yeah, because practically they're equivalent, right? Technically, they're equivalent, more or less. What really is the very big difference between the RDF and Sparkle world is the fact that if you provide your data as RDF, somebody else can import it into any one of their technical stores. While if you have a property graph, you might even have a standardized query language, but there's no standardized data model, and there's definitely not a standardized data interchange model, and you can't just merge node identifiers, which comes back much more tomorrow than in this talk. And that really becomes very, very important, because when you start doing this integrative data science, which in biology just becomes extremely critical, then RDF, with its way of actually identifying nodes consistently with URIs, becomes a key killer feature that the property graph people haven't looked at. That's not their target market at the moment, and they haven't really seen things. What they do have a little bit more is the built-in graph analytics, shortest paths, Dijkstra's kind of thing approach, which would be nice to have in Sparkle, but currently it just isn't standardized. Ori, I saw your hand raised.
Yeah, well, it's kind of, I've seen some of these queries, so they can be surprising, and putting a surprising query in a benchmark is it's kind of tricky, because you would end up with it's very difficult to do that. In my current occupation, there's also a lot of big schemas and tons of tables, and there's also interest in systematic analysis of performance. But this benchmarking thing is always like an abstraction of something complicated that you distill into something that's a lot simpler. And I guess that's why these big schemas and these unions of 1,000 things don't occur in benchmarks. And of course, especially going back to Sparkle query optimization is next to impossible. And it is surprising that these things actually work as well as they do. In OpenFacts specifically, it's our experience that query optimization takes the bulk of the time. In actually the semantic publishing benchmark, as simple as these queries are, there too, if we execute for 10 milliseconds, it can be that 7 of these 10 are taken by compilation. So, we see some of these effects, but these effects in benchmarks too, but the effects are more pronounced, certainly in the wild. But yeah, it's difficult to replicate the wild in benchmarks, just because you'd end up, making all this diversity.
Is your query log available?
No, not the public query log because HIPAA kind of things. People might be looking up healthcare information. What this terrible queries that you see, I actually put it in a grant that we submitted 3 weeks ago to say that we're going to propose all these horrible queries, that kind of style, as a benchmark proposal to the LDBC. So that is something that if that grant gets accepted, you'll get them plus a data set plus correlated to pre-executed queries.
The torture test.
Yes.
Have you done any analysis
Or do you have
of query
torture?
logs? Do you know, is there, I mean, do you have portable surprising queries, but can you categorize them in a handful of types of queries? Are they star-like or snowflake-like? I mean, that.
I think what you could say the deep optional trees. That is one of the most common ones, which is a bit tricky. So there's from what we see from the biologist side, from the biologist kind of users, they're very targeted. They're extremely targeted. Get very large queries, but that tends to be in the end bound by a very special predicate because the distribution of these predicates is extremely log-based. So you have ones which are extremely common, and then there's ones which are very, very rare. And those tend to be the ones that the biologists tend to use. So they go for the rare data because that's the rarely valuable data. Because, well, we might have a big data problem and we have a small knowledge. So we have lots of data, but very small knowledge. And the biologists tend to ask for, what do you know? And not like, well, what did you just manage to bump into the database? So we find that those very, very large queries actually tend to be very, very selective and therefore get pretty good results. When you go into the more queries which are more analytics, when you start doing sums and counts and order by, when you do kind of tree-based counting, that can be quite tough. But they come back. They're okay. It's when they start doing the full text analysis as well that becomes terrible.
Regex are quite impossible to do in RDF. It's just the worst case that can be.
Yes, but it would be, so almost I think it would be better if you just did a regex full table scan of all the data and then just build a bit set of the predicates which have been hit, something like that. I think it could be better than what it's done, but I can also completely understand that no commercial provider wants to support this because it's one of those things where if you know your own data, it doesn't make sense to do these kind of regexes. But when you kind of have somebody else's data and you're just trying to randomly look in it and you want to use completely standard Sparkle, then it becomes a bit of a tricky one.
I haven't heard of anybody like us having a full text index that supports regexes, for example. I mean, such things have been heard of, but I'm not aware of anybody having such.
No. But then it would stop doing the regexes, we would hope, than if you have full text index. But we actually found out nobody, so we had been using Virtuoso, and we actually looked at the query logs over 3 years, and nobody had ever used BIF contains.
Yeah.
So that's when we decided we can drop the full text index because nobody's using it.
Yeah.
Why maintain it? So that was an unexpected one. We thought, well, just have a look. Maybe it'll be 10 users, but it was actually none.
But you could have stored procedures for user-defined functions and stuff like that.
Yes, and that is something that we'd like to see some more standardization work on shippable, customable functions, and I think there are some possibilities there.
Well, it's not going to happen in Sparkle, but in the case of Virtuoso, you do have a procedure language that you can expose in Sparkle.
Yes.
So you can make a few of those,
Yes, what we actually almost imagine is like people can the database can download a Docker image, and the Docker image contains just the function. Then the database engine pumps data into the Docker function and out on the other side from the Docker function and completely isolated like that. So you can somewhat send random compute to databases, which gets security-wise very, very tricky, but we'll see.
Well, sending compute, of course, if you do it one by one, it's not even, it's unfeasible next to, but if you, what do they want to compute?
Could be hidden Markov models on our sequence data. So very, very biological functions, scoring matrix calculations, somewhat like Levenstein calculations, but different approaches. So they might have very biologically relevant compute that you might want to push into the database.
And that's an aggregate over a lot of data, or what is it?
Could be aggregates, could be full kind of regex kind of things.
Yeah.
So scans over lots of literals, quite
Yeah,
expensive
well,
compute.
A diversity of all kinds of things
Yes.
tend to be inefficient.
Yes.
Okay. Well, I guess you can only do them case by case.
Yeah, most of the time. And most of the time for our end users, they're complaining too much that downloading the data takes too long. So if you could just send us the compute and build it somehow, you'll be quite happy. Just to avoid the download problem.
Yeah. What about having it uploaded at Amazon so anybody can have their own instance of it and then write all the stored procedures they want and run them on their own virtual machine?
Well, then they all have to use your implementation of the stored procedures, and then.
Well, I mean, they could write them in C, and of course there's a bit of
That's already a high barrier to cross for many.
Yeah, but there's a little bit of a specificity, of course. No stored procedure language in any SQL world either is exactly interoperable.
Yes.
But they kind of tend to be alike.
Yeah. So on the Sparkle side, you could actually have interoperable versions. Because if you just take the Sparkle result set as input and give a Sparkle result set as output, like Sparkle application or JSON, that could work. But that's a bit besides the point of.
But you don't want to send data over any serialization like that. You just want to run it in the engine. And a stored procedure will actually do that, but even efficiently. But you just have to know how to write them. And from my time at OpenLink, I don't remember a single user ever writing a stored procedure. Even those stored procedures are very useful. And it seems to be, across the SQL world, the stored procedures, as useful as they are kind of being underutilized. Of course, every vendor does all their stuff in their own procedure language, but the users tend not to.
Because every vendor does it its own way. That's a bit the issue.
Yeah.
Okay. Any other questions or? No?
So,
Megan?
well,
Yeah.
so do you have thought about a methodology to look at all the queries that don't work? Just to get them more.
Yes, it's called. You look at the query log, and we look at the query log and look at the last log, 5 queries before the thing crashed. So there's not work. That's the user problem. They might come to us and send us to the help desk and ask us, this query isn't working. Can you do something about it? The ones that we naturally log at is basically it triggered an error in the implementation, and we need to figure out how that happened. Do we need to ban this kind of stuff temporarily? Do we need to open a support issue? Funnily enough, what we do actually get is people download our data. You have an in-house data warehouse with our data, and they still ask us well, we were trying to ask this question. How do we do it efficiently on implementation X, Y, and Z? So that gets quite interesting when we don't know certain implementations what's good or not, and you basically ask, how could you write this query to go faster? And then we kind of answer, well, in our experience with vendor A, you could maybe try this, and we heard that this might work as well, and we can try those kind of things. So it's not just the public server that is being used. We also get help requests from people who have downloaded our data in commercial settings. And we see those.
Okay, so now we're going to go on break.